Hi friends, welcome. In this video, I am going to talk about division related techniques. In particular, I will talk about divisions, divisibility and roots. So let's start with division. So first case is when the divisor ends in 9. So the name of the Vedic technique is Ekadhikain Purvain. So let's do some examples and see how it works. So let's take the example of 1 over 19. Here we add 1 to 19, so it becomes 20. So then we divide 1 by 20 and it becomes 0.1 by 2. Then we write the expression like this where we say 0 point in bracket remainder and then quotient. And then we divide it by 2. And whatever remainder and quotient we get, we write next to the previous one and we keep repeating it. So when we did 1 by 2, we got 0 as quotient, 1 as remainder. So now we have 10. So 10 by 2 is 5 quotient, 0 remainder. Then 5 by 2 is 2 quotient, 1 remainder. Then 12 by 2 is 6 quotient, 0 remainder. Then 6 by 2 is 3 quotient, 0 remainder. Then 3 by 2, 1 quotient, 1 remainder. Then 11 by 2, 5 quotient, 1 remainder. Then 15 by 2, 7 quotient, 1 remainder. Now if we have to get the answer, we just have to pick the quotient part from the above expression. So we get this answer. So now let's do one more example. Say 5 over 119. So we add 1 to 119 and it becomes 120. Again we divide 5 by 10 first, so we have 0.5 by 12. And we write again in the same form where in the bracket we write remainder and next to it we write quotient. So 5 by 12 is 0 quotient and 5 remainder. Then 50 by 12 is 4 quotient, 2 remainder. Then 24 by 12 is 2 quotient, 0 remainder. Then 2 by 12 is 0 quotient and 2 remainder. Then 20 by 12 is 1 quotient, 8 remainder. Then 81 by 12 is 6 quotient, 9 remainder. Then 96 by 12, 8 quotient, 0 remainder. Then 8 by 12, 0 quotient, 8 remainder. Then 80 by 12, 6 quotient, 8 remainder. Then 86 by 12, 7 quotient, 2 remainder. Then 27 by 12, 2 quotient, 3 remainder. Then 32 by 12, 2 quotient, 8 remainder. Then 82 by 12, 6 quotient, 10 remainder. Then 106 by 12, 8 quotient, 10 remainder. Then 108 by 12, 9 quotient and 0 remainder. And we can keep on doing like this. Now to get the answer, we just have to pick all the quotients from the above expression. So we get this as answer. Now let's take the next case where the divisor is closer to some power of 10 but less than it. So here the name of the Vedic technique is called Nikhilam Sutram. So let's do some examples and see how it works. So suppose we have to divide 4389 by 98. So 98 is 2 less than 100. So we write 2 like this. And since 100 has 2 zeros, so we write 2 as 02. It should have 2 digits. Then we split quotient and remainder part like this, where because 100 has 2 zeros, so in the remainder side we will have 2 digits and the rest of the digits will come on the quotient side. Then the most significant digit of the quotient is put down like this. Now we individually multiply this difference. So 0 is multiplied with 4 and then 2 is multiplied with 4 separately. 0 and 2 are treated individually, not as a combined number. So then 0 times 4 goes here and 2 times 4 goes here. Then we add 0 and 3 and we get 3. And we repeat the same process with 3. So 3 times 0 goes here and 3 times 2 goes here. Now when we have a number below the rightmost number in the remainder, then we stop doing this exercise. So since now 6 has come under 9, so we stop it and we add all the numbers. So when we add 9 plus 6 becomes 15 and 8 plus 8 becomes 16 here. Now one of the 15 goes to 16 and one of the 16 goes to 43. So 16 becomes 17 and 43 becomes 44. So this is 75. Now since 1 has moved from remainder side to quotient side, we have to multiply 1 with this difference of 2 here. So 75 plus 1 times 2 is 77. So our quotient is 44 and remainder is 77. Let's do one more example. So now suppose we have to divide this number. Now here 987 is close to 1000 and 1000 has 3 zeros. So we will write 13 as 013, and in this case the remainder will have 3 digits and the rest of the digits will go to quotient, and again we put down the most significant quotient as it is below, and we multiply the digits of this difference individually. So 0 times 6 0, then 1 times 6 6, and 3 times 6 18. Then we add 3 and 0, we get 3. So 039 goes like this. 2 6 and 0, we get 8. Then we again individually multiply and we get 0 8 24. Now 24 comes under 6, which is the rightmost digit of remainder. So we stop this process and we add all the numbers. Now 3 of 30 will go to 25, so it will become 28. Now 2 of that will go to 28, so it will become 30. And then 3 of 30 will go to 638, so it will become 641. So on the remainder side we have 080 plus, since 3 moved in from remainder to quotient, so we have to multiply 3 with 13. So when we add them together we get 119, and 119 is less than 987, so our quotient is 641 and remainder is 119. Now let's take the case where the divisor is closer but more than some power of 10. So here the name of the Vedic technique is Perverted Sutram. So let's do some examples and see how it works. So in this case 13 is 3 more than 10. So we write here 3 bar, which is a way of saying 10 is 3 less than 13. So 3 bar means minus 3. So from 13 we have to subtract 3 to get to 10. So we write 3 bar. And like in the previous example of Niklam Sutram, 10 has 1 0, so remainder will have only 1 digit and the rest of the digits will go to quotient, and the most significant digit of the quotient will come down as it is, and we will multiply 3 and 5. So since 3 is negative, so it becomes minus 15, and bar shows the negative sign. So 7 plus minus 15 is minus 8. So now minus 8 minus 3 is 24. Now we add 6 and 24, we get 30. So 30 times minus 3 is minus 90. So minus 90 comes under 8, which is the rightmost digit of remainder. So 8 plus minus 90 is minus 82. So how do we simplify it? So 5 minus 8 is nothing but is 50 minus 8, which is 42. And then we move 9 from 30 towards 82. So 90 minus 82 is 8. And since we have subtracted 9 from 30, so we get 21 here. And 9 has moved from quotient to the remainder side. So we have to multiply 9 with the 3, which is the difference between 10 and 13, and add to 8. So we have 35 here. So our numbers are now 42, 21 on the quotient side, and on the remainder side 35. So 42 and 21 means 441, because we have to add this 2 and this 2 together. Now 35 is more than 13, so we will find out the remainder and quotient here again with 35 by 30, so which comes out to be 2 quotient and 9 remainder. So this we have to add to 441. So we have 443 as quotient and 9 as remainder. Let's do one more example. So here 112 is 12 more than 100, or 100 is 12 less than 112. So we put 12 bar, and 100 has 2 zeros, so the remainder will have 2 digits here. And again the most significant digit of the quotient will come down as it is. So we follow the same steps, minus 6 and minus 12. So we add 2 and minus 6, we get minus 4. So minus 4 times minus 1 is 4, and minus 4 times minus 2 is 8. Then we add 5 minus 12 plus 4 is minus 3. So minus 3 times minus 1 is 3, and minus 3 times minus 2 is 6. Then we add 7, 8 and 3, we get 18. So 18 times minus 1 is minus 18 and 18 times minus 2 is minus 36. So minus 36 is under 3, which is the rightmost digit of remainder. So we stop this process and we add all the numbers. So here we get minus 33 and minus 4. Now 6 minus 4 minus 3 is nothing but 600 minus 43. So which is 557. Now we move 1 from 18 on the quotient side to the minus 4 of the remainder side. So it becomes 10 minus 4, which is 6. And then from this 6 we move 4 to the ones place of the remainder side. So 40 minus 33 is 7 here. And this becomes 6 minus 4, 2. Then we have to add 12 times of 1 because 1 moved from quotient side to the remainder side. So now we have 39 here. 39 is less than 112. So the answer is quotient is 5587. 8 because we have to add 1 of the 17 here to the 7 of 557. So answer is 5587 quotient and 39 remainder. Let's do one more example. Let's do one more example. So here 1012 is 12 more than 1000. So we put bar over 12 and we have 3 digits for 12. So we have put 0 over here. And then we follow the same technique. So here because 1000 has 3 zeros, so remainder will have 3 digits. Now let's take the next case where the divisor is such that it is not close to any power of 10. So in this case what we do is that we multiply both dividend and divisor with a factor to make the divisor closer to some power of 10, and then we apply the Nikhilam or the Perverted Sutram as appropriate. So once we get the quotient and remainder with the new numbers, quotient remains the same, but we have to divide the remainder with the factor that we had multiplied the original number with to get the actual remainder of the original number. So let's do some examples and see how it works. So 28 is not close to any power of 10. So we will multiply it with 3 to make it 84, which is 16 less than 100. And we will follow the Nikhilam Sutram. Now we have to divide 75 by 3 because we had multiplied 28 by 3. So the answer is 166 quotient, 25 remainder. Now let's do the same calculation with a factor of 4. So here we have to divide 100 by 4 because we had multiplied 28 by 4. So we get 25 as remainder. So again the answer is same. Now let's talk about the general Vedic technique of division. So suppose we have to do this calculation. So what we do is that, so first we write the numbers like this. So one's place of the divisor is separated out like this, and the rest of the number of the divisor is over here, and the one's place of the dividend is kept separately over here, and the rest of the number are put in the middle. Now since 283 has 3 digits, so we first take the first 3 digits and we divide it by 283. So this is, so 579 by 283 is 2 quotient and 13 remainder. So we write quotient here and remainder here. In the next step it becomes 133, and then from 133 we have to multiply these two numbers. We have to subtract 2 times of 4. So this is 125 by 283, which is 0 quotient and 125 remainder. So for the next step we have to subtract 0 times 4 from 1256 and we have to divide it by 283. So we get 4 quotient and 124 remainder. So we put 4 here and 124 here, and for the next step we have 1242 minus 4 times 4 divided by 283. So we have 4 quotient and 94 remainder. So we put 4 here and 94 there. Then for the next step we have 941 minus 4 times of 4. Because it is on the remainder side and it is less than 2834, so we stop here and our answer becomes quotient as 2044 and remainder as 925. Now let's talk about divisibility. This shows the divisibility rules for various single digit numbers. Now let's first learn about oscillators. So what are oscillators? So you take the numbers ones digit and multiply it with a number so that ones digit of the result of the multiplication becomes 9. So for numbers that end in 1, we have to multiply it by 9 so that the result of the multiplication will end in 9. For 3, we have to multiply it by 3. For 7, we have to multiply it by 7. For 9, we have to multiply it by 1. For even numbers, we have to divide the number by 2 until the ones digit is an odd number. And if the odd number happens to end in 5, then we have to keep dividing the number by 5 until it becomes an odd number that is different from 5. So this is the step number 1. Now at step number 2, we multiply the entire number with this factor. So say we have to find out the oscillator for A, and we have found out based upon its ones digit that we have to multiply it with n. So to make the ones place of the result of the multiplication 9. Then we will have rest of the numbers in B. So the oscillator for A is B plus 1. So example for 7, we have to multiply 7 by 7, so we get 49. So the answer for 7 is 5, which is 4 plus 1. 5 is the oscillator for 7. Similarly for 21, we have to multiply it with 9, so it becomes 189. So 18 plus 1, 19 is the oscillator for 21. For 543, we have to multiply it with 3, so it becomes 1629. So 162 plus 1, 163 is the oscillator for 543. So how do we use oscillators to get the divisibility test for a given number? So suppose the dividend is of the form n d0, where d0 is the digit on the ones place and n represents the rest of the number, and divisor is d and s is its oscillator. So the divisibility test for divisor d is, so d will divide n d0 if it divides n plus s times d0. For the number, you take its digit on the ones place, you multiply it with the oscillator of the divisor and you add the rest of the number. If the divisor divides it, then the divisor will divide the original number as well, and you can apply it repeatedly until the number becomes so small that you can directly check. Now let's do some examples of divisibility with oscillators. So suppose we have to divide by 23. So our divisor is 23. So for 23, the oscillator is 7. So let's take an example. So in this example, 4472 divided by 23. So we take the ones place of 4472, which is 2. We multiply it with 7 and add 447 to it, which is the rest of the number other than the ones digit. And we repeatedly apply it. So we get 53, which we can easily check that it is not divisible by 23. So the number 4472 is not divisible by 23. Let's do one more number. So it is divisible by 23. So 4462 is divisible by 23. Now let's do one more example. Say our divisor is 247. So for 247 the oscillator is 173. Now suppose we have to check if 92837 is divisible by 247 or not. So here we separated the ones digit and we multiplied it with 173 and we added rest of the digits, and we will do it repeatedly. So we can easily check that 336 is not divisible by 247. So the original number 92837 is not divisible by 247. Now let's check this number. So now this number is divisible. Let's take one more example. Say it is 76. So now 76 is 4 times of 19, and for 19 the oscillator is 2. So suppose we have to check if 6536 is divisible by 19 or not. So first we will check the divisibility test of 4. So 36 by 4 is divisible is 9, which is divisible by 4. So since 36 is divisible by 4, so it passes the first test. Now the second test is whether the number is divisible by 19 or not. So here we separated out 6. So 2 times 6 plus 653, and we will keep doing it. So now this number is divisible. Now the issue with oscillators is that if the number is very big, then it will take a lot of repeated steps to come to a number that is small enough that can be checked easily for divisibility. To speed this process up, we will use a next technique where we will find out the remainder by dividing various powers of 10 with the divisor. So suppose the divisor is an n-digit number like this. So first what we do is that we divide the dividend in chunks of n digits starting from right side. Then we find out the remainder when we divide 10 raised to the power n by the divisor. So suppose this number is m. Then for each chunk we find out its remainder with the divisor. Then we calculate this sum, and if this sum is divisible by the divisor, then the original number is divisible by the divisor. So we will do some examples and see how it works. For 7, let's first calculate the remainder that we get when we divide various powers of 10 by 7. So for 10 raised to the power 0, which is 1, the remainder is 1. For 10 raised to the power 1, the remainder is 3. For 10 raised to the power 2, 3 times 3 is 9, 9 by 7, the remainder is 2. For 10 raised to the power 3, we have to multiply 2 and 3, 6 divided by 7, the remainder is 6. For 10 raised to the power 4, we can do 6 times 3, 18 divided by 7 is remainder is 4. For 10 raised to the power 5, 4 times 3, 12 by 7, remainder is 5. For 10 raised to the power 6, 5 times 3, 15 by 7, which is 1. So now the cycle will repeat. Now suppose we have to find out whether 8736524 is divisible by 7 or not. So what we will do, we will calculate the remainder for each of these digits when divided by 7. So 8 by 7, the remainder is 1. 7 by 7, the remainder is 0. 3 by 7, the remainder is 3. 6 by 7, the remainder is 6. 5 by 7, the remainder is 5, and the same way for 2 and 4. Now we are going to multiply this remainder with this remainder at each place. So 1 times 1, 1. 5 times 0, 0. 4 times 3, 12. 6 times 6, 36. 2 times 5, 10. 3 times 2, 6. 1 times 4, 4. Now we are going to add these numbers. So here we get 1 plus 0 plus 12 plus 36 plus 10 plus 6 plus 4. It is 69 by 7. So we can clearly see that 69 is not divisible by 7. So the original number is not divisible by 7. So 8736524 is not divisible by 7. Let's do one more example. Suppose we have to find out if 7398439 is divisible by 247 or not. 247 has 3 digits, so we will have 10 to the power 0, then 10 to the power 3, and then 10 to the power 6. Now 10 to the power 0 is 1, so factor is 1 here. For 10 to the power 3 is 1000 divided by 247, the remainder is going to be 12, because 247 times 4 is 988, which is 12 less than 1000. So we will have 12 for 1000, and for 10 raised to the power 6, it is 10 raised to the power 3 times 10 raised to the power 3, which is 12 times 12, which is 144. Now we will split the numbers. So 439 will come over here, 398 will come over here, and 7 will come over here. Then we will take the remainder for these 3 numbers. So the remainder of 7 remains 7. 398 divided by 247, the remainder is 151. 439 divided by 247, the remainder is 192. Now we are going to individually multiply each part. So 144 times 7 is 1008. 12 times 151 is 1812. 1 times 192 is 192. Now we are going to add these 3 numbers, and we are going to get 3012. We will again follow the same thing. So 3 times 12 plus 12, which is 48. 48 is not divisible by 247, so it is not divisible. Now let's change the number slightly and make it 391. So here it becomes 391, and here it becomes 144, because 391 divided by 247, the remainder will be 144, and 144 comes here. If we add, we get 2964, and if we divide 2964, we get 2 here and 964 here. If we find out the remainder, we get 223. So 2 times 12, 12 from here, plus 223 is 247. So this is divisible by 247. So this reduces the number very quickly, which we can easily check if the original divisor can divide the number or not. Now let's talk about roots. So we will talk about square root, cube root, and other roots. So let's talk about square root. So for a number that ends in 1, the square will also end in 1. For a number that ends in 2, its square will end in 4. Number that ends in 3, its square will end in 9. Number that ends with 4, its square will end with 6. Number that ends with 5, its square will end with 5. The number that ends with 6, its square will end with 6. A number that ends with 7, its square will end with 9. The number that ends with 8, its square will end with 4. And the number that ends with 9, its square will end with 1. So it's very easy to find a square root of numbers up to 6 digits. Suppose we have to find out a square root of 237169. So it is ending with 9. So which number's square is ending with 9? So 3 or 7. We don't know yet if the number will end with 3 or 7. And we have to find out the largest number whose square is less than this number. So what that number is? So if we do 48 square, we get 2304. If number is greater than the square of 485, then we have to pick 7, and less than the square of 485, then we have to pick 3. The square of 485 is going to be 48 times 49. Whatever number we will get, we have to put 25 in the front. So if we do 48 times 49, we get 2352. So 2352 is less than 2371. So which means this number is more than the square of 485. So it must be then 7. So the answer is 487. Let's do one more example. Now let's talk about cube root. So same way. So number ending with 1, its cube will end in 1. Number ending with 2, cube will end with 8. Number ending with 3, cube will end with 7. Number ending with 4, cube will end with 4. Number ending with 5, cube will end with 5. Number ending with 6, cube will end with 6. Number ending with 7, cube will end with 3. Number ending with 8, cube will end with 2. Number ending with 9, cube will end with 9. So now let's do this. So here, since we have to find cube root, so we will split at the last third digit. So since it is ending in 9, So from here we know that the ones digit of the number will be 9. Now we have to find out the largest number whose cube is less than this number. If we do 8 cube we get 512, and if we do 9 cube we get 729. So here we have 679. The most significant digit of the cube root must be 8. Now we have to find out number in the middle. So we take cube of 87. So without doing full calculation we realize that cube of 87 must start with something less than 66. Now let's check 88 cube. So without doing full calculation we realize that it will start with 68, so which is more than 67 here. So our answer is going to be 87. Now let's do other roots. For numbers ending with 1, all its powers will end with 1. If the number ends with 2, its square will end with 4, cube will end with 8, power 4 will end with 6, and power 5 will again end with 2. If the number is 3, its square will end with 9, its cube will end with 7, its power 4 will end with 1, and its power 5 will end with 3. For numbers ending with 4, their square will end with 6, cube will end with 4 again, and power 4 will end with 6 again, and it will alternate like this. For numbers ending with 5, all its powers will end with 5. For numbers ending with 6, all its powers will end with 6. For number ending with 7, its square will end with 9, its cube will end with 3, its power 4 will end with 1, and power 5 will again end with 7. For number ending with 8, its square will end with 4, its cube will end with 2, its power 4 will end with 6, and its power 5 will again end with 8. For numbers ending with 9, its square will end with 1, and its cube will end with 9 again, and then it will alternate. So here, so for 2 and 3 the cycle size is 4. For 4 the cycle size is 2. For 7 and 8 cycle size is 4. For 9 cycle size is 2. So how do we use this? So let's do an example and find out. So suppose we have to find 15th root of this number. For 15th root we will take 15 digits from the right and split. This number is ending with 8. 15 mod 4 is 3, so it means the number will end with 2. Ones digit of the answer will be 2. Now the remaining number is 15. So we have to find out largest number whose power 15 is less than 15, so that number is 1. So answer is 12. Now let's do one more example. Say we have to find out 18th root of this number. So here again from the right we take 18 digits and we split the number there, and here it is ending with 9. So it could be 7 or 3. Now we have to find out largest x whose 18th power is less than this number. So if you take log of 2 you get 0.301. If you take log of 3 base 10 you get 0.477. So if you multiply it with 18 you get 5.4 and 8.5 respectively. It means 2 raised to the power 18 will be a 6 digit number, whereas 3 raised to the power 18 will be a 9 digit number. Since it is only 8 digits, so here we will have 2. The reason we picked 27 and not 23 is that 23 is a prime number, and 18th power of 23 wouldn't be divisible by anything other than some power of 23, whereas this number is divisible by 3 as we can see from the digits. So that is why 27 is the answer. So this completes the video. I hope you liked it. Please share your comments, thoughts and other topics that you would like to see videos on. Thanks for watching. Please subscribe to my channel if you have not done so already, and please hit the like button and bell icon. Enjoy.